Okay, so one of the things that we did last class period is this. We went back and forth between moles and mass. Mass is just a fancy way of saying grams, right? So if I give you grams and you have a periodic table at your disposal, can't you pretty easily use a conversion, a little table of death to go back and forth between grams and moles? If it's a compound or a molecule, you might have to add up the molar masses to get to it, but still pretty straightforward. We also went from moles to particles. Now, let me remind you, a mole is 6.022 times 10 to the 23rd anythings. Well, we typically refer to those anythings as particles, and the three particles we work with the most are atoms, molecules, and formula mass units, depending on what we're actually dealing with. Now, we went from here to here and from here to here. But the reality is that it's just easy to start on this side of our little table and go all the way across to particles, or vice versa. And to that end, we're going to do the problem that's on the board right now. I don't know if you guys can see this here. I want to convert 493.61, an oddly specific number, of CO2 to molecules of CO2. Yeah? So if I look at my table over here, aren't I starting this problem with grams? And I want to get all the way over to particles, which in this case are called molecules. Agree? But in order to go from grams to molecules, do you realize I have to do a pit stop first in moles? There's no way to go directly from grams to particles. So let's do that together, shall we? And this is something that will look oddly familiar because it is what we've been doing before. And I'm going to start off with my table of death with 493.61 grams of CO2 in the upper left-hand corner. I know that some of you guys here do not like writing either the units or the number in here, but it's really important to do that because particularly when we get to the next section where we're going to be working through equations or through reactions, these things will change and you have to be able to cancel them out. So if I'm at grams and I want it to moles, mustn't I use the molar mass of CO2? Now, I already know what the molar mass of CO2 is, but when we add up the molar mass of one carbon plus two of the oxygens together, and that's going to give us 44.01 grams per mole. I just happen to have done this a lot of times. You're wondering how I got that? Again, carbon's 12.01, and then each oxygen is 16.00. So that's how I got that number. But that allows me, if I have grams per mole, couldn't I put the 44.01 grams on the bottom of CO2 and 1 mole of CO2 on the top? Now that allows me to cancel out grams of CO2, and we're at moles right now. If I solve this problem right now, I would have moles of CO2, and that's essentially what we did last class period. But in this particular problem, they don't want us to stop at moles, they want us to get to molecules. So if I want to go from moles to molecules, isn't the conversion that we're going to use always 1 mole is equal to 6.022 times 10 to the 23rd anythings? So if I want to get to anything, in this case being a molecule, couldn't I use the conversion 1 mole is equal to 6.022 times 10 to the 23rd molecules of CO2? Now, if it had been an ionic compound, I would have called it formula units. If it had been an element like copper, I would have called it an atom. Don't be confused by the wording here. They're just particles. But in my problem right here, I'm going to then have to go like this. I have 1 mole on the top, and I want to use 1 mole equals 6.022 times 10 to the 23rd molecules. So I'm going to put my 1 mole of CO2 on the bottom and my 6.022 times 10 to the 23rd molecules on the top. Cancel out moles, end up at molecules. Yeah? So if I put my unit out here, molecules of CO2. Oh, sorry, I didn't put CO2. Thank you. Good catch. I have an exponent here, 10 to the 23rd, don't I? And I still kind of am old school, even though your calculators can do this for you. I like to put the exponent in and then just do the math. And when I multiply this by this and divide it by this, can someone punch that in really quickly on your calculator? Jacob, it looks like you're on your way.
67.5419.
67.5419. Agreement, Jacob? Okay. Again, I like this number, but don't love it. It's not in good form, which means I probably want to shift this decimal place 1 place over and make it 6.75419 times 10 to the 24th. Plus, I started off with 5 significant figures here, but didn't I use 4 significant figures for my molar mass? So I should use 4 significant figures in my problem, which is right here, which gives us 6.754 times 10 to the 24 molecules of CO2. Now, isn't this very akin to what we did at the very beginning of the year when we went from like miles to inches? Yeah. And we go, all right, let's go from miles to feet. because we know that conversion. Let's go from feet to inches. This is literally all we're doing. Now, I could do a reverse problem. You want to do a reverse problem?
Yep.
Okay, let's do a reverse problem. Again, this is going to be completely random because I can. Let's do given 8.321 times 10 to the 26th formula mass units of NaCl. What is the mass? I want to get used to the terminologies of NaCl. Now, you realize that I call this a formula unit of NaCl because it's an ionic compound, yeah? And when I'm setting this up here, aren't I now starting on the far right-hand side with particles? And in order to get from particles all the way over to mass, mustn't I do a pit stop at moles? So we're going to be doing the same steps over and over again like we did before. Just depends on where we start off. In this case, we're starting off 8.31 times 10 to the 26th FMU of NaCl. And I know that the conversion is this, 6.022 times 10 to the 23rd FMU of NaCl for every 1 mole of NaCl. Do you guys see how I use the 1 mole equals 6.022 times 10 to the 23rd and put it in such a way that the particles, aka FMUs, got canceled out? Yeah? So FMUs get canceled out. Now I'm at moles of NaCl and I want to get to grams. Whenever I want to get between moles and grams, mustn't I use the periodic table and the molar mass? So if I set this up right now, I'm going to go 1 mole, and then on top here I have to do the molar mass of NaCl. Let's do that really quickly. I think Cl is 34.45 or 35.45, sorry. 35.45 plus Na is 20.99 or 21.00. If we add the two of those together, what do we get? 36. You can't add 35 and 21 and get 36. 56.45. I knew that's what we were going for. Isn't that the grams of NaCl for every 1 mole of NaCl?
Mm-hmm.
A little bit. That allows me to cancel my moles, and I'm ending up in grams. And grams is the unit that I'm looking for in this problem. So I'm going to write grams of NaCl out here. Now, in this case, don't we have 2 exponents that we can work with here? We have 26 and we have 23. I like to deal with exponents first. Whenever you have something on the top and something on the bottom, you subtract your exponents. So wouldn't that give us times 10 to the 3rd?
Now if you do it, you get 78.
You got, jump the, what do you get?
78.0007.
007. Just in case you're wondering how lickety split boy over here did this, did he go this times 1? But come on, right? Times this and then divided by this 6.022. Again, you know my feelings already. I like that number. Not in love with it, right? Because it's not in good form, nor does it have the correct significant figures, if I'm not mistaken, right? So I'm going to shift the decimal place left D largely, right? 7.8007 times 10 to the 4th. Again, these are the units. And if I look at my problem, originally I only had 4 significant figures. So if I have only 4 significant figures, I have to cut it off right here. That's going to make it 7.801 times 10 to the 4th. Now, quick refresher here. This right here on the board, that pathway, that's what we're going to be following over and over again. Now, it depends on where we start. Just know where you're starting. If you're starting at the middle, can't you go either way in one step? But if you're starting on one side, you've got to go all the way across, or you can stop wherever you want. Now, one of the things I've seen people do is this. They're at moles and they have to go to particles. I literally have seen this and I'm going, why? They'll go moles to grams and they go, okay, got to go back to moles and then go back to particles. Like literally they just went whoop, oh, whoop. And then they did it like in a 4-step process instead of a 1-step process. So your homework right now is going to be the remainder of those 2 worksheets for next class period. Should be really straightforward. That's all I have to say about that.